Welcome to True Projects. In this video, we are going to explain about the project, which is a blockchain-based access control model for student academic record with authentication. Introduction of the project. In the evolving landscape of educational institutions, manually verifying and updating student credit information on physical documents poses challenges such as damage, mix-ups, and resource-intensive process. The digital transition offers efficiency but raises concerns about data security. This project addresses the need for a secure and efficient system to manage and authenticate student credit information. The prevalent use of centralized databases in institutions are vulnerable to various security threats, including data breaches, injection attacks, and buffer overflow attacks. Hardware issues necessitate server shutdowns, impacting the overall system. Proposing blockchain technology, the project addresses the vulnerabilities in centralized databases, enhancing security and resilience against data breaches and hardware issues in educational institutions. Blockchain is a decentralized digital ledger technology that securely records transactions across a network. It creates immutable chain of blocks, each containing transaction data. Utilizing decentralized consensus, it ensures transparency and tamper resistant. Beyond cryptocurrencies, blockchain has diverse applications providing enhanced security and efficiency in various industries. Various blockchain types like Ethereum, Bitcoin, Stellar, and Ripple exist, each with distinct features, governance models, and use cases. This project utilizes Ethereum, known for more than transaction recording. It supports smart contracts that autonomously manages tasks like data storage and retrieval without central authority. Ethereum strengths include dApp creation, an engaged developer community, security enhancements, and compatibility with other blockchain projects. Objective of the project. The objective is to establish a secure access control model for student academic records to the blockchain technology. The goal is to enhance security, transparency, and data integrity in the management of academic information. The goal is to streamline manual record keeping process, reducing time and energy consumption. The objective is to transition to a blockchain based system for more efficient and resource effective record management. The objective is to address security vulnerabilities associated with the centralized storage of student data. The goal is to minimize risks such as data breaches and attacks by adopting a decentralized blockchain approach, thereby strengthening overall data security. The aim is to implement a robust security framework with three blockchain layers. This includes data storage blockchain for secure data storage, the access control model blockchain for added layer of security around data activities, and authentication blockchain. The goal is to validate transactions and user login securely. The objective is to enable secure validation process for transactions and user logins involving authorities, institutions, and students accessing the data storage. Leveraging the authentication blockchain and smart contracts, the goal is to ensure a high level of security in these crucial interactions within the academic record system. To implement this project, we need requirements, and the requirements are: coming to software requirements, we need Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, MetaMask, which is a Chrome extension. Backend languages which are required are Python, JavaScript, Solidity. Hardware requirements are processor of i5 and above, RAM of 8 GB and above, ROM of 20 GB and above. Coming to front-end languages, we need HTML, CSS, JS, Bootstrap 4. Framework is Flask. To implement the project, we have designed various steps in the methodology. The first step is sign up. Here, we have sub-modules which is institution sign up. Educational institutions can register for the system, providing necessary information to create an account. The next one is authority sign up. Authorities such as administrators or faculty members or company members can sign up by providing required details to access their designated functionalities. The next one is institutional login. Here we have submodules which is enroll students. Once logged in, institutions have the ability to enroll students into the system, entering relevant student information. The next one is upload certificate credential. Institutions can securely upload and store certificate credentials for enrolled students. The next one is view students. Institutions can view the list of enrolled students and their associated details. The next one is student login. Here, upon logging in, students can view and verify their personal details stored in the system. and students can access, review their academic credentials such as certificates and records. Students can see any access requests received from the authorities or institutions regarding their academic records. The next module is authority login. Here we have submodules, which is send access request. Authorities, after logging in, have the capability to send access requests to students for viewing their academic records. Access certificate. Authorities can access and view the academic certificates and records of students who have granted them permission. Blockchain integration. The project involves the development of a blockchain based access control model for student academic records. This implies that blockchain technology is used to securely manage and control access to the records, ensuring authentication and authorization process are decentralized and tamper resistant. The project incorporates a three-layered blockchain security framework comprising the data storage blockchain, access control model blockchain, and authentication blockchain. Each layer utilizes blockchain technology to enhance the security of data storage, access control, and user authentication. The data storage blockchain is a layer dedicated to storing student records in blocks using cryptographic codes to link them. This ensures the tamper resistant and security of stored data with the decentralized nature of the blockchain preventing unauthorized access. The final layer based on Ethereum blockchain is the authentication blockchain. Here, blockchain technology is utilized for user authentication process through smart contracts. It ensures the secure validation of transactions and login processes for authorities, institutions, and students accessing the data storage. Blockchain integration includes leveraging IPFS to securely store certificates in hash codes. IPFS enhances the security and accessibility of stored certificates within data storage blockchain, providing a decentralized and tamper-resistant solution for certificate management. Ganache. Ganache is a user-friendly interface for monitoring Ethereum blockchain activities. It simplifies tracking of accounts, transactions, and smart contracts, making it accessible even for users without in-depth blockchain expertise. Ganache offers detailed transaction information including sender, receiver, amounts, gas usage, and success status, and aiding debugging and ensuring transaction accuracy. It also tracks smart contract deployments, confirming correct deployment and functionality. This transparency simplifies monitoring and verification process. Ganesh lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, which is gas, was used. Ganesh also enables data retrieval from the stored blocks, allowing developers to access and analyze specific block informations. Ganache is employed to access the data on local Ethereum blockchain, encompassing information regarding medical report, student records, etc. MetaMask. MetaMask is both an Ethereum wallet and a browser extension. It simplifies cryptocurrency management. In the project, MetaMask ensures secure Ethereum transactions, promoting transparency by displaying deduction of ETH as fees. This transparency maintains accuracy and ensures confident, reliable financial interactions in the project. To execute the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the contracts folder. This folder consists of files related to Solidity code. It handles data structures, functions, and events with modifiers for validation. Here we have static folder, which contains files related to CSS, JavaScript, and Bootstrap. These files contribute to the visual and interactive aspects of the application. Here we have templates folder. This folder consists of files related to HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. To execute the project, first we need to host the server. For that, I'm opening Ganesh. So here we can see that server has been hosted. Now we will get back to the code folder. So this is IPFS BAT file. IPFS is a decentralized file storage system for secure and distributed data sharing. Blockchain is effective for recording transactional data, but for large file storage, it integrates with the IPFS. So now we need to double click on it to start the IPFS server. Here we can see that IPFS server has been running. Now we will get back to the code folder. This is the run.bat file. Instead of executing the project through command line interface, we have created this Windows bat file. Now we need to double click on this run.bat file to start the Flash server. So I'm double clicking on it. Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. This is the local host and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser. And this web page is built by using the Flask framework. Here we can see various links, which are institution login, authority login, and student login. First, we need to click on the button institution login. As institution has not signed up, first we need to sign up as an institution. For that, we need to click on this new institution sign up here link. Here we need to provide all the essential details of the institution. So the institution name is Vignan. Address is Hyderabad. Contact number of the institution. Username. And the password. Now we need to click on sign up. Here we can see that institution sign up task is completed and the institution details are safely recorded in the blockchain. Now we need to sign up as authority. For that, we need to click on authority login. Here we can see new authority sign up here link. First, we need to click on that to sign up as authority. Here we need to provide all the company details. So the company name is True Projects. Address of the company. Contact number. Username. And the password. Now we need to click on sign up. Here we can see that company sign up task is completed successfully. And these records are saved in the blockchain. Now we will sign up as the institution. Sorry, we have already signed up as the institution. Now we will log in as the institution. For that, we need to click on this institution login link. Here we need to provide institution credentials, which are the username and the password. So I'm giving username and the password of the institution. Now click on login. So here we can see that institution has logged in successfully. And here we can see various links, which are enroll students, upload certificate credential, view students, and log out. So first we need to click on enroll students to enroll the student details. Here we need to provide student details. So the student ID is 4. Student name is Kishore. Here we need to provide the password, course name, and the joining date. So I'm choosing the joining date as year is 2020, July month, and the date is 1st. Now we need to click on enroll. So here we can see that new student enrollment task is completed. Action. As we did few transactions, now we will check the fluctuations of the ETH price with each transaction. For that, we need to open the MetaMask, which is the extension. So I'm opening the MetaMask. Here we can see ETH price is reducing for each transaction. Now we will see how the data has been stored in the blockchain. For that, we need to open Ganache. So here we can see that the data has been stored in all these blocks. And for each block, we can see the date and time at what time it has been stored. So we will open the block number 18. Here we have the block hash code. And here we have the transaction hash. So I'm clicking on transaction hash. Here we can see sender address of the block, to contract address of the block, gas used, gas price, gas limit, and the transaction hash. Now we will get back to the web application. Now the institution has to upload the certificate of the student. For that, we need to click on upload certificate credential. For that, we need to first enter the student ID. So the student ID is 4. Certificate details are graduation. And the issue date is 13 December. And now we need to click on choose file button to upload the certificate. So I'm uploading the third certificate. Now click on open. And now click on upload certificate. So here we can see that the certificate is saved on IPFS with the hash code saving in blockchain is this, which is hash code of the certificate. Now we need to click on view students so that the institution can view all the student details. So these are all the student details which institution can see. Now click on log out. Now we have to log in as student. For that, we need to click on student login. Here we need to provide student credentials, which are the username and the password. So the username is Kishore and the password. Now click on login. Student has logged in successfully. Here we can see various links which are view your details, access your certificates, view access request and log out. First, we need to click on view your details so that student can view all his details. Here, student can see all his details. Now we need to click on access your certificates so that student can see what are all the available certificates with him. Here, student has 3 certificates: school name, student ID, certificate details, issue date, file name, hash code, and the certificate. Here we have all these things, and these can be viewed by the student. Now we need to click on view access request so that the student can see what are all the requests he has received from the authority. So here we can see no access request has been sent. Now we will log out of the student. For sending the access request, first we need to click on authority login. Here we need to provide the credentials of the authority. So I'm giving the username and the password. And now we need to click on login. So authority, which is company, has been logged in successfully. Here we can see various links which are send access request, access certificate and logout. First we need to click on send access request. Here company can see all the school name, student ID, student name, school details, course name, joining date and send access request. So company want to send request to Vigyan. So in this fourth column, in the first column, which is fourth row, here we can see a click here link. First we need to click on that so that the company can send access request to student Vigyan. Here we can see that access request sent is successfully. Here we can see that access request sent to student number 4. Now click on logout. Now we need to log in as student so that we can grant access to the authority. Here we need to provide our credentials again. And now click on login. And here we need to click on view access request. Here we can see that he got the request. So we need to click on click here link so that the student can grant access. Here we can see that access request granted to the company True Projects. Now we will log out of the student and log in as authority. Here we need to provide the credentials again. Now we need to click on access certificate so that we can see, which means company can see whether student has granted certificate access or not. So here we can see that Vignan student has been granted his certificate details. Now we will log out. In this way, by using the blockchain, student academic records can be manipulated and it can be controlled. Conclusion of the project. The project's successful implementation of a robust blockchain-based security system ensuring the integrity and confidentiality of student academic records through the three-layered approach. A key takeaway is achieved efficiency in record management, reducing the time and energy previously expended in manual procedures. The transition to a blockchain based system has streamlined process for enhanced activities. The project has effectively addressed security risks associated with the centralized data storage by adopting decentralized blockchain technology. The vulnerabilities to data breaches and attacks have been mitigated, providing a more secure environment. The implementation of blockchain has contributed to enhanced transparency and data integrity. The decentralized nature of the system ensures that records are tamper resistant, fostering trust in the accuracy and reliability of the student academic information. The project emphasizes the successful establishment of secure validation process for transactions and user logins. Leveraging the authentication blockchain and smart contracts ensures a high level of security, safeguarding critical interactions within the academic record system.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.